So today we will see how to interface IO device to 8051. The most common used IO device here that I am going to teach is an LED and an LED and a switch. So these are the two devices that we are going to look into. So let's look at each one of this LED and switch, how to interface. So let's take an example of interfacing an LED. So we will see how to interface LED. So interfacing LED to 8051, we can do it with three ways actually. So considering a picture of this is, let's say this is 8051 microcontroller. So this is my 8051 microcontroller. I have it here. So this is my 8051. This is 8051. This is microcontroller. And you have here port 1.0, and I can take even port 3.0, and I will take another one is port 2.0. So I'm going to interface this with different possible way, like the LEDs. So in one of the interface I will connect an LED here, directly connecting the IO pin to the ground. So this is one of the methods. So here this is directly connected to the ground. Okay, so we have here this is LED 1. So L1 is this. Another case we are going to have a pull up connection. So from the point I have an LED here. So this is going to be my plus 5 volts connection. So here is plus 5 volt and here is a resistor. So this is a resistor R and this is the LED. In one more connection I can have an LED using a transistor. So I can drive an LED using even a transistor. So a connection like this. This is connected to the base of the transistor, and here I have the same 5 volt connection I can get. So this again a limiting resistor R1, and this is the emitter. Emitter will be grounded. So this is transistor T, and I think I missed LED here. I need to connect an LED here. So let me have LED here. I need to connect an LED here this way. Yeah, this is an LED. So it is L1 and this is L2 and this is L3. So these are the three ways of connecting an LED to 8051. I can have it in the first case. I can have it straight away from the port. I can connect an LED. The only thing here is the port is having an internal pull-up. In 8051, if you see, there is an internal MOSFET and there is a pull-up. So this has come to P1.0 like this. So this is already connected with VCC internal. So I'm just connecting an LED like this. So if I make a connection, the current flows through like this. The I, which is already limited by this R. So this is a typical connection that we are following. So in another case, what we do here is we have a pull down, this one. So here logic 1 makes it on, logic 0 makes it off. So here in port 3.0 is connected to an LED in a different type. So what happens here, logic 0, when you make it logic 0, the current flows like this. So VCC is here, the current flows through this LED and the LED turns off. So the logic 0 is responsible for turning on, whereas logic 1 is responsible for turning off. So LED will turn off because of logic 0. So if you see the internal connections, what happens, there is a MOSFET internally and there is a pull-up like this, and this is P3.0. What happens, you are connecting separately and pull-up and then a LED like this. So what happens here, the current flows through this way and sinks at the MOSFET. So logic 0 is responsible to make this kind of a connection. So in the next case, it is similar to the first case where logic 1 is responsible for turning on. So how it is possible, when you put logic 1 at the fourth pin, this transistor will turn on and the current flows through like this. So LED is also on. In case when you do logic 0, transistor becomes off and LED also off. So this is another way of connecting an LED. So these are the three techniques you can use. So every technique, this is the most used technique that is possible. We can with the minimum components we can use. Other two, it depends on the current rating. So but don't be careful in choosing this R and also this R depending. So this is the most preferred connection. So using a transistor, we can have any type of current rating in this particular technique. So moving on to the next one. So how do you interface a switch? So we can also interface it connecting the switch. So connecting a switch. So if you are connecting a switch, what is the way? So connecting a switch in 8051 is very simple. Imagine this is my 8051 microcontroller. So this is my 8051 and I have a port pin here P1.0. I want to connect a switch. So best method is from the port you connect a switch and put it to ground. So this is S1. So in some case we can also have a connection from the switch, connect it to ground, and preferably let's say I'm using port 0.0. So I need to connect a pull-up. So you need to connect a pull-up and this is your VCC. So this is your switch S1. This is S2 and this is my S1. So these are the two possible ways of connecting a switch to 8051. So in this case, the only condition is the port should be at logic high. They should be at logic high. So you need to retain your port at logic high. So in that case, So once you make it here logic 1, logic high, once the switch is pressed, so once it is pressed, this point is connected to ground, so this becomes logic 0. So once you press, it becomes logic 0. If it is open, it becomes logic 1. Similarly here, the port is already at logic high. Once you press it, this ground is connected to this point, so this point will be at 0. So when it is closed, when you close it is 0. When it's open, then this is at logic 1. So these are the two ways you can differentiate the state of the switch. So let's have a simple interfacing example to solve a problem. So let's have an example in which okay, so we can have an example here. Interface LED with 8051 microcontroller and control LED using a switch. Let's say this is the question. So I need to control an LED using a switch. So basically I am going to perform this. So let me draw up. So what is a possible solution for this? The solution is simple. So let me start with the solution. So I need to have a first circuit diagram. So let me have a circuit diagram first, a simple switch and LED. So this is my 8051 microcontroller. So this is 8051 microcontroller and this is sorry, and I'm going to connect an LED here. So let me have an LED connection over here. This is my LED. Straight away grounded because the internal pull-up will take care of limiting the current. So this is my LED connected to P1.0. Okay, and I will connect P1.1 with the switch. So I'm going to connect a switch here. So switch, I will connect it. So this is connected to ground actually. This is also connected to a ground. So this is a switch here. So this is the LED L and this is the switch S. So L1 and S1 are the. So now I need to interface this. I will write a small program here how to write a program. So program is very simple. So let me write a program. Program is like this. So first I need to set bit P1.1 that is to make it as an input and clear P1.0 turn off, and I need to check the status of the switch. Jump if bit. So I need to check the status. So I need to check the status here. Jump if bit p1.1 p1.1 jump if bit means it is open, so I need not do anything. So if it is closed, that means this condition jump if bit indicates it is 1. 1 means the switch is pressed, switch is open. So in that case I'm not pressing, so that will get logic 1. So if I'm getting logic 1, I feel that switch is open. In that case I will not do anything. And if it is closed, then this will be no bit. So I will put a logic here in a separate way. Then if no bit, then it is closed. That's better. Closed. Switch is closed.